Datsun, Honda, Toyota. These are names that have made a tremendous impact in the U.S. auto market because of excellent engineering, efficient production methods, and a relatively inexpensive labor force. These companies have caused the major automakers in the U.S. to reassess their marketing concepts and production methods. We are now faced with the same competitive challenges as the auto industry by the Komatsu line of crawler tractors. The Komatsu crawlers cannot be taken lightly, and a knowledge of their strengths and weaknesses is necessary to maintain a selling advantage. The Komatsu D-155A competes directly against the TD-25C. The D-155A has more weight, has more horsepower. However, overall performance and operator acceptance justifies a critical comparison between the two tractors. The TD-25C and D-155A are both powered by turbocharged diesels. The DTI 817C is manufactured by International, and the S6D-155-4 by Komatsu. A comparison of the two engines shows they're quite similar, with the exception of Komatsu's slight horsepower advantage. Therefore, while engine performance is practically equal, a higher price and fuel consumption is paid with the Komatsu. To illustrate this point, the fuel cost for the D-155A is approximately $5,100 more than the TD-25C over a 10,000-hour life in average working conditions. In today's economy, this is an important sales consideration. The D-155A incorporates a torque converter transmission combination called torque flow. The converter is a conventional three-element, single-phase, single-stage design. It's very much like the converter in the 25C in that it's unit constructed for easy accessibility. Primary differences in powertrain operation begin with the transmissions. Komatsu has adopted Caterpillar's planetary multiple-disc clutch design. This transmission requires many moving parts and offers only 3 working speeds. In addition, shift controls in the D-155A are partially mechanical. This means periodic adjustment is needed. In comparison, the TD-25C's transmission is International's countershaft design with less moving parts, more speeds, and full hydraulic controls. Hydraulic controls ensure positive engagement with no adjustments necessary. A look at the working speed ranges of the 25C and D-155A illustrates the advantages in speed-to-load matchups with International's countershaft transmission and 2-stage planetary steering system. The servicing of a planetary transmission has always required a great deal of downtime. The structural complexity and number of parts used in construction of a planetary transmission should be considered as a time and cost factor. Removal, repair, and reassembly of this type transmission is a complicated procedure. Let's compare steering systems. In reality, there's no comparison because International's 2-stage full planetary power steering is unsurpassed in its class in the market today. Independent full power to both tracks while turning is a feature that cannot be matched by any competitive crawler. The D-155A steering system is a conventional slip-type multiple-disc steering clutch with foot-operated wraparound asbestos brakes. The problem with this system is the dead track effect in negotiating a turn, along with the mechanical over hydraulic controls that require occasional adjustments. Let's examine the single-lever steering control on the D-155A. A 2-pedal system controls the steering brakes, while a 2-lever system controls the steering clutches. The clutches interconnect with the brakes, therefore, a direction turn can be made under single-lever control without depressing the steering brake. This system allows the operator a choice of all hand steering or the option of hand and foot steering. It would appear to be very functional. However, a look in the operator's compartment shows the crowded atmosphere created by the many levers and pedals. Conversely, the TD-25C's true hands-only steering with no additional foot pedals on the floor, creates an uncluttered working environment. A turn is accomplished by simply pulling one of the levers located close to the operator for ease of operation. Now there's a major difference between the 25C and 155A in final drive design. Both machines use a double reduction final drive, with the first reduction being pinion to bull gear. However, International uses a planetary second reduction, while Komatsu retains a second pinion to bull gear set. The advantage of the planetary type is that torque is distributed evenly over 3 symmetrically located gears, as opposed to one bull gear in the Komatsu. This reduces the tendency to break gear teeth under high torque shock loads. A comparison of track frames illustrates primary differences in track frame construction. The D-155A utilizes a box section type design, which is simply 2 box sections bridged by a metal floor. The top of the frame is a welded plate, forming a housing to protect internal components. The 25C uses a fuselage type track frame, which consists of a single steel plate. It's formed into an inverted U shape, and internal bracing is used to give the frame additional strength. Fuselage track frame design is considered one of the strongest types in the industry. A 3-point track suspension, in contrast to a 2-point, has the advantage of shorter diagonal braces, resulting in an unobstructed underbody. This gives greater ground clearance over more area and guarantees track alignment in all planes, no toe in or toe out. Komatsu's 2-point track suspension requires a heavier diagonal brace that must be extended to the front idler to prevent toe out. Ground clearance indicated in the spec sheet is confined to the center of the machine only. The 25C's 3-point suspension is a definite advantage over the 155A's 2-point. The equalizer bar incorporated in the 25C is an international exclusive. It's manufactured of forged steel that enables it to flex. This feature allows the bar to give the ride of a spring and the blade control of a rigid bar. The shock-absorbing cushions used in the 155A's equalizer system can deteriorate and lose their elasticity. This could cause increased servicing problems and downtime, resulting in loss of production. A 3-piece ring-type bolt-on replaceable sprocket is utilized in the TD-25C. This design extends sprocket life and produces true and even wear. The 9-piece segmented sprocket of the 155A could possibly require welding of the segments for additional strength, and this increases cost. An evaluation of track link design will show a major difference between International's concept and Komatsu's. The 25C incorporates a track link with a strut, thereby increasing strength and durability. This lengthens track link life and reduces costs. The 155A uses a strutless track link. The primary problem with this design is one of strength. A strutless track link cannot absorb the great amount of twisting stress that a strutted link can withstand. It should be kept in mind that most major competitors use the strutted track link. Because the steering levers are mounted in the dash in the 155A, the dash must protrude. A look into the operator's compartment will illustrate that this design makes it difficult to enter or leave the compartment. It can also increase operator fatigue because of the necessity to reach for the levers. The 25C, on the other hand, has a true walk-through compartment. This is because International believes operator comfort should be considered in machine design. The steering levers are located close to the operator, so they can be easily reached. The 25C provides maximum operator comfort and ease of operation. Production is one of the most important factors in the sale of a crawler tractor. It should not, however, be the only consideration when evaluating machines. Other factors, such as operator comfort, operating cost, and particularly, in the case of Komatsu, parts backup and availability, should be prime considerations. The slight production advantage of the D-155A should not outweigh the overall quality offered in the TD-25C. The D-155A outproduces the 25C by approximately 8% when both tractors are equipped with their standard blades. Komatsu has this advantage because of a 1.2 cubic yard larger blade, slightly more weight, and 10 more horsepower. This does not necessarily reflect, however, a lower cost per yard. The extra weight and horsepower of the 155A over the 25C means it also consumes more fuel. Therefore, fuel cost per hour is greater than the TD-25Cs. This production curve illustrates the advantage of the 155A over the 25C when both units are equipped with their standard blades. When both units are equipped with the same 12.5 cubic yard young blade, the production advantage of the 155A is negligible. The D-155A is a machine to be reckoned with in the TD-25C size class. The few advantages it has over the 25C could cause problems when selling against it. Therefore, it's important to know the key advantages the 25C has over the 155A. Two-stage planetary steering, planetary final drives, countershaft transmission, and the economical DTI 817C engine give the edge to the TD-25C on a comparison basis with the D-155A. Another prime factor in selling the 25C is the fact that there's no problem in servicing or parts availability. The 25C is backed by an extensive and solid distributor organization, a claim that cannot be made by Komatsu at this time. The TD-25C can be sold with confidence against the D-155A. However, if Komatsu increases the size of their distributor organization, a thorough product knowledge will be essential in selling against the 155A.